Valve has several hardware announcements today and some operating system announcements. The company is announcing its Steam Machine mini PC with SteamOS. Also, the Steam Frame VR headset with separable compute portion, accompanying Steam Frame VR controllers, and the new Steam controller. There are multiple aspects of software wrapped into these, so SteamOS on ARM, FXEMU, Proton updates, and of course SteamOS for desktop. So at our own expense, we booked some plane tickets, a hotel, and flew out to Valve to get some A-tier engineering discussion about all this stuff. We have thermal, acoustics, electrical engineering teams we're talking to today for the news announcements that Valve has.
And what happens is when the signal transitions through, it hits that, and some reflections go through the via, and they resonate and cause interference. We had more CFD hours on this thing than an F1 team has in the calendar year.
If you hit it with ESD, it doesn't blow out the front end of the chip.
It's interesting because there's a displacement, but then there's also velocity and there's also acceleration.
Some details remain nebulous. The release for all of this is sometime in 2026. The Steam Frame, in the very least, they're targeting early 2026. Pricing is TBD, but we have kind of rough estimates where we were told the Steam Machine, so that's the computer. It's like kind of, it's not really a console. I mean, it's a computer. It just kind of looks like and is positioned like a console, but it's more open than that. That is supposed to be priced as what they called a, quote, entry-level computer, and they made sure to specifically say it would be not priced like a console, but like an entry-level computer. Where that range falls is kind of a personal choice for everybody, but it sounds like it's going to be more than a console. One of the biggest challenges Valve is going to run into is this. That's right, this might look like a stick of RAM that just 2 weeks ago was worth maybe about $30, but today it is worth about $60. And so we'll see how that DRAM market shakes out as they approach the launch 2026 for the Steam Machine, but that's definitely going to impact the pricing decisions if it's still crazy like it is now. Valve told us that the Frame headset won't be priced higher than an Index. It was non-specific though on which SKU or bundle, if at all. As for this video, we're going to focus on news and engineering interviews for each component. We have at least 2 separate videos coming up after this that we split out, and we split them because it was like literally all engineers. It was actually, we have a lot of cool information, and we want to keep that density. We don't want to just chop it all up and put it in here. So we're going to have a separate video on acoustic, thermal, and power engineering for the Frame VR headset. If you're not into VR, it's still pretty interesting. And then we also have another one on the Steam Deck with one of its engineers. No announcements there, but pretty cool stuff. And we might also have some more on the Steam Machine coming up too. But for now, let's get into the specs and the news for SteamOS, which is a Linux-based operating system, the Steam Machine, VR, the controller, and then the controllers for VR. This video is sponsored by us and our AI Dystopia Kickstarter-style fundraiser. We posted a video yesterday about the time someone from the Secret Service spoke to us about a company we investigated, and we detailed the AI Surveillance Dystopia series that we have coming up, which we're funding entirely through support from the audience, on our own store at store.gamersnexus.net. As part of this, we launched our brand new Retro IO drink coaster packs, made of a rubberized material with 3D height differences in components. Each coaster pack comes with 4 distinct coasters, one retro-style computer front panel with 5 1/4-inch drives, and even a floppy disk in the slot. It's got knobs, dials, and retro gray color matching. One video game controller themed around the USPTO's favorite customer. One IBM Model M inspired numpad with carefully curved borders and large keycaps. And the GN Retro case style logo with careful object positioning to balance your drinks. We just launched these yesterday with our AI Dystopia series fundraiser, and already it's one of our fastest selling launches ever, accompanied by our 4 backer tiers for the upcoming series of investigations and special reports on troubling partnerships like NVIDIA working with Palantir, and game publisher connected raids of people's homes for dev kits. You can watch that video to learn more. The tiers include things like the coaster packs, our new censored Vaporwave smiley t-shirt, our Snowflake the Data Pirate cat metal doubloons for your tabletop gaming sessions, and bonus behind the scenes videos, group Q&A sessions with me, and more. This directly supports our upcoming series of deep dive. Head over to store.gamersnexus.net to help us directly, while you get something unique in return. It also helps us independently pay for travel to events like these. Thanks for your support. Back to the news. Up first, Valve has attempted to launch Steam machines before. I was there in the before times at GDC in 2014 or 2015 when a bunch of system integrators had basically mini ITX computers that Valve sort of said, look, it's not like literally a Steam machine, but if you call it that, we can't stop you. That's what they had. Never came out. They just launched its ITX computers from SIs, and that kind of killed the project there. It is coming out now, but unlike last time, Valve's going first party for hardware. SteamOS is available to partners if they want to work with other companies on it. So in theory, other people could build their own. I guess it would just at that point be a SteamOS box. But they are now deploying SteamOS for their first significant first-party supported desktop, or basically desktop deployment with a Steam machine. That's important as well. So let's start with the Steam machine and the specs. The Steam machine uses a BGA solution with SODIMM memory and modular M.2 storage, shipping in 5 12GB and 2 TB models with the micro SD card slot for additional storage, and there's an optional Steam controller bundle. Micro SD cards can be pulled relatively seamlessly between the Steam Deck and the Steam machine and transplanted between each other with games on them. It should be simpler than Windows in that way. The CPU is an AMD 6-core 12-thread Zen 4 processor with its IGP fused off, and the GPU is a separate semi-custom RDNA 3 28CU chip that supports ray tracing, which RDNA 3 does. The 28CU solution is paired with 8GB of GDDR6 VRAM, and then RDNA 3 was the RX 7000 series, so the 32CU RX 7600 would be relatively close by pure CU count comparison. There's other specs to consider as well, but just by CU count, this would be a little bit below that. System memory is separate at 16GB of DDR5 5600 laptop memory. For rear ports, the Steam machine has one DisplayPort 1.4, one HDMI 2.0 with CEC, one 1GB per second Ethernet, one USB Type-C 3.2 Gen 2 10GB per second, and two USB 2 Type A ports. There are also two USB 3 Type A ports in the front, 2x2 Wi-Fi 6E, and another two separate antennas for Bluetooth and one specifically for the Steam controllers. Out of the box, it ships with SteamOS, although you probably didn't need us to go to Seattle to tell you that part. That much seemed obvious. Our biggest immediate concern by looking at this is definitely just the thermals. Looking at how closed off the box is in general, there's not a lot of space at the bottom. That's where most of the air is going to come in. There's a little bit of space at the front. You can take the front panel off, and that opens it up a lot. But we can't really pass too much judgment on it till we have it to benchmark, which we will definitely be doing. Valve did do a lot of tuning on thermals, so they have a single larger, for this size machine, 120mm fan that's used as a pull solution. So that'll pull through the bottom and the holes in the front. It'll pull a lot through the holes in the front if you remove the front panel. But as always, there's trade-offs. So if you pull that front panel and more air comes in through there, less is going to come through the bottom. Something else might not get cool as much. Anyway, we'll test all that as soon as we have it in. There's a lot of thermal testing to do for that one. And acoustics too. We'll definitely be putting that in the acoustic chamber. But there were two critical shortcomings with the original Steam machines, the ones that predate this one. For some quick history, the first critical shortcoming was Valve did not ship them. That's kind of the main one, really. The second was that Valve was working with third-party suppliers, that'd be system integrators in this case, iPower companies like that, to make small form factor PCs as Steam machines. They did not intend to do large first-party runs at the time, other than a beta run. And there wasn't really a great reason to use the 2015 version of SteamOS from that time. It was nowhere close to where it is today. SteamOS just was a much higher path of resistance than using Windows, and Windows wasn't yet at peak spine on U capacity.
And so essentially we just feel like now is the right time for us to make these happen, just because we finally feel like we have the software and the hardware pieces all figured out.
Right.
By all accounts, the SteamOS experience on Steam Deck, people love it. They love the convenience. We're seeing a lot of people use their Steam Deck to dock to their TV.
Right.
Primarily to us, that just means that that console experience is there, but we just simply feel like if we were to make something that's more intended for that use case, that doesn't have the weight and battery life limitations, we can give those people a much better experience.
Now you might look at the Steam machine and our footage and think, if not console, why console shaped? And it's really simple. It's because it is a small form factor computer. That is all it is. It's an SFF PC with SteamOS on it, and that's a good thing. That's really what we want, because it has most of the modularity of computers. So it doesn't have the CPU and GPU, those are BGA solutions, but you can still open it up and change things. You can access BIOS, so we're talking about that. Valve says it's more like a laptop style BIOS, in that it is not going to have as many options as, say, like the Asus motherboard for desktop or something. But they did say that, quote, you can play around with frequencies. So there's some level of tuning you can do in BIOS. We asked Valve about its choice to go with the BGA Zen 4 solution rather than something socketable, seeing as that benefit from AM5's likely immortality if it's anything like AM4. And Valve considered modular CPUs and GPUs, but settled on soldering both chips to the board for thermal and size reasons. Unfortunately, this means it's not upgradable because they're soldered to the board, but it gives them more control over it, makes it smaller. The CPU has a peak frequency of 4.8 gigahertz from what they told us, which sounds similar to an R5 7640U. It's not exact, but it's kind of getting there. It falls short of something like an R5 7600 from desktop. Now, the silicon's off the shelf. It's an AMD semi-custom solution, so Valve worked with AMD to do some tuning on the CPU. It's not a lot from what we understand. It sounds like basically they fused off some parts they're not going to use, like the IGP. They did whatever tuning they want to do on the volt frequency curve, and then otherwise there's firmware customization, software customization, of course, and then the fusing off of certain elements. Now, the 28CU GPU, from what Valve is saying, operates typically at about 2.45 gigahertz under load, although its peak opportunistic boost would be higher. If you're familiar with AMD's terminology, they sort of have two boost states. One is like a nominal boost under load, and then the other one is peak opportunistic boost.
I mean, I was on the motherboard, so I'm really proud of how small it is for what it is. It's, you know, both the CPU and the GPU is on it. We use the same thermal module to cool everything. So both the CPU and the GPU, the memory, and the FETs as well are all connected to the same thermal module.
Do you know, off the top of your head, the sort of power consumption during peak load or nominal load?
So the GPU is anywhere between 110 and 130 watts.
Okay.
We're still dialing that in, to be honest. The CPU is closer to 30 watts.
Okay.
And you know, once you add in memory and peripherals and all that kind of stuff, we're typically in the 200 plus watt range.
Now, in a later discussion, Valve locked down the GPU to 110 watts. We asked about the chipset. Valve said it's routing all of the I/O through the CPU rather than using an AMD chipset on the motherboard. This is an option with AMD. You can just go through the I/O die on the CPU. That is something that they support. We asked about the VRM. We'll have to wait for the teardown to get final answers, but here's what they said. Here's what Yazan knew off the top of his head.
It's 6-phase for the GPU.
Okay. That's kind of what I was getting at.
Yeah, and then for the CPU, we have 2 or 3 phases. I don't remember exactly. The problem is like there's different rails. I'm trying. So like the GPU does like 6-phase for core, 2 or 3 phases for memory. For the CPU, it's I think total about 4 phases.
Okay.
Split between different rails.
VSOC and vCore and whatever, Power is handled by a 12-volt solution. It's only 12 volts. On a pure technicality, it's not necessarily 12 VO in the sense that it is using a blade connector instead of going through cabling. So this helps with a lot of things, primarily space, but there are other benefits as well. And it's a 300-watt power supply that's mated directly to the motherboard with the blade connector. Valve is doing something we want to give them credit for here, which is a lot of the mini PC companies, they are able to claim a smaller volume by shipping an external power brick with it instead. So it's kind of cheating at the numbers because there's still an external thing. They didn't shove it in the box, which means volume number lower and lower number better on that graph. So Valve shoved the power supply in the case, and that means they are taking up a decent amount of the Steam Machine's volume with a true internal power supply. Valve says that it hits over 92% efficiency in, quote, most scenarios, end quote. And given the thermal challenges and the space constraints, we think it's cool that they shoved it in here, and we're looking forward to taking it apart more.
We spent a lot of time thinking about airflow. Living room is actually a really challenging thermal environment, right? Like people can shove them in corners, put them behind things. So we thought about how do we have intake and exhaust that is hard to block. Somebody who's not really thinking about it, like, so we have bottom intake, so airflow kind of just flows around the front here, through here.
Okay.
And then we also have perimeter intake here, 360, again, because it's really hard to block every single one of those.
Right.
And then finally, we have exhaust on the back because if you have cables attached here, you can't really push it all the way against the wall, so we always guaranteed some space.
Now, the legs are short, which we pointed out, but Valve says that its goal for whatever this is worth, and we'll do all this testing once it's in, but was to fit under a 6-inch shelf in a media unit. We probably don't need to test that. Probably just look at a spec sheet for that part. But the thermals we're going to test, and that makes sense for a living room environment. They were telling us that the design team was fighting over fractions of a millimeter, and so a difference in 0.5 millimeter of height on the feet on the bottom actually became a big deal if they're trying to fit within certain, I guess, media entertainment type furniture you would have under a TV or something. Valve claimed that the leg height, as it is now, assuming it's not on carpet, still allows for 95% or thereabouts of flow performance as compared to a fully unrestricted bottom intake, meaning if you had an infinitely open bottom suspended in air, they think that they're close to around 95% of what they would be able to get in that situation. So we'll test that as soon as we get it in. We have all the tools for that. And you do absolutely need to make sure this does not go on carpet, though. And Valve did point out that they're going to say that in the manual or something to that effect. So as soon as it's on some surface that will conform to it, it's going to be a bad time. Valve had some interesting solutions to its airflow and size limitations. There's a plastic ridge on the bottom of the machine, and that is intended to block hot exhaust from recirculation, which it does simply by just dropping down slightly lower to the floor. Under normal conditions, we were told that the airflow split between the bottom vents and the perimeter vents should be 50-50. The rear of the case is made of metal for the highest possible porosity while remaining sturdy and complying with the various regulations for exposed fans. And the front is a magnetic plastic panel with the intention that users can print their own, maybe with better airflow. Now, Valve did show us some other closed panels, but they were pretty cool. So one example was an e-ink display that Valve won't be selling, but that they were using for testing. You could make one of these yourself if you were crafty enough. The relatively large aluminum fin stack is mostly a single shared solution. It contacts the CPU with phase change TIM, uses paste for the GPU, and then thermal putty for the rest. It doesn't directly contact the system memory or the storage. Neither of those are soldered to the board, though. The heatsink has 4 heat pipes that look like roughly 8mm solutions paired with a single custom 120mm exhaust fan at the rear of the box, using a custom cowling that gives slightly more depth in some areas of the fan, which would enable better pressure performance. Using an axial fan rather than a blower for a device of this form factor is unusual and created design difficulties, Valve told us, as opposed to, for example, the PS5, where it just uses a gigantic blower. Now, the benefit of blower fans is static pressure performance. They are also pretty good at exhausting the heat out of a small enclosed box. The fan in this instance, axial one, is focused on static pressure. It ranges between 500 to 2,000 RPM, and it's got a blade to frame, tip to frame clearance of somewhere between 0.5 to maybe 1mm. It's a big range, but Valve wasn't certain offhand what that clearance was, and also wasn't certain if the material is PBT or LCP or what it may be.
One of the questions that people are asking is like, how did you arrive at this architecture? And the answer, I think, is probably going to be surprising to most people, which is we literally designed the fan first.
Okay,
cool. Because like when the laws of thermodynamics are not flexible. Like if you know how much heat you're trying to remove, you can, and you know what the temperature the GPU is trying to reach, that tells you how much airflow you need. If you know how much airflow you need, you can get to design the fan. So we really started by looking at what's on the market, how much airflow they can get at what static pressure, playing with blade geometries, like getting the optimal fan that we can. The
last thing on the thermal solution is we're probably going to do some Schlieren imaging for this one because it'll work perfect for it. I mean, we can test the sort of recirculation blocker at the bottom really easily with Schlieren imaging, and then we can also take a look at how the air enters and exits based on that front panel attachment. So that'll be fun for us once it actually launches. The memory is upgradable with disassembly of the machine. It is laptop memory. We're not sure if it's 2 sticks or 1 at the moment. Replacing the stock M.2 2230 SSD is easier. It's directly exposed, and there is enough room for a standard 2280 drive. We had a really interesting technical discussion. It's kind of a side shoot. It goes into PCB design and memory trace routing. And so this was cool, where the GPU is GDDR6 memory, VRAM, and that poses some unique challenges, Valve was telling us, where they ended up using a 10-layer PCB because of the memory solution. But here's the clip.
Adding layers is typically done because you need the layers for routing, and that's for us was the main reason because we needed to. GDDR6 is really hard to route.
Okay. Why is that?
It's a lot of signals, very high-speed signals. You know, they're very dense, so it takes a lot of layers to do that. And also, GDDR is pretty power hungry, so you have to kind of use some layers for power routing and then other layers for signal routing.
And is it still true that each trace for memory needs to be the same length?
Yes.
Okay.
Yep. So you have to time delay match. It's not even the same length. It's time delay. So you have to like keep in mind the propagation delay because the top layers will have slightly different propagation delay than the middle layers. So you have to keep that in mind. Impedance as well. Right. So they have basically all the bits have to arrive at the same time.
Right.
The speed of light, down to I think like a picosecond, if I remember correctly. GDDR6 is, as I said, really challenging. So like we have to do things like back drilling. I don't know if you're familiar with that.
I don't think I am.
It's basically like when you have a hole through the board to transition through layers, it's just a through hole. So if you're trying to go from like layer 1 to layer 5, you have a stub that goes all the way down to layer 10.
Got it.
And what happens is when the signal transitions through, it hits that, and some reflections go through the via, and they resonate and cause interference.
Is this the same as a via, or is it different from a via? Because vias I'm familiar with.
It's basically, if you think about like the path that the signals take, right? They go from layer 1, and then go to layer 5, and they continue on layer 5. Because the via has to go through the whole board, there's a path where it doesn't take, right?
Okay,
like a stub, like it's a junction in the road, and the signal wants to take one way, but there's the other one, which is a byproduct of just the manufacturing technology. So we have to go back and drill that path and remove it. So the signal doesn't travel both paths and cause interference.
Cool.
Back drilling removes part of the via to only the part you're using.
Finally, there's a customizable LED bar on the front of the machine that's used as a status indicator for when the display is off. For example, it can show download progress of games. And of course, we're well equipped here to test the thermal, power, flow, acoustics, all that stuff on this. I'm actually excited to turn all of the equipment on it because this is like exactly what we are set up to do here. So as soon as it's out, you'll want to check back for all of that. But let's move on to the next part, which is the Steam Frame. The Valve Steam Frame's key feature is its bandwidth-saving Foveated streaming solution, which takes its naming and some of the concepts from Foveated rendering, but applies it to streaming. The frame is built modularly with a separable, fully contained, face-mounted ARM architecture computer running SteamOS. Now, we last covered VR in detail with the HTC Vive and the Oculus Rift. It's been a little while. That was back when the industry was a little crazy. Everything was branded with 2 letters on every device. VR. Fortunately, these days, as an industry, we've moved past using 2 letters to sell everything. Okay, look, it's not a good example right now, but now Meta's own ARM-based solutions are something we're popular right now, and Valve did launch the Index in the meantime, since the old HTC Vive that it partnered with them on, and it says that the price ceiling for the frame should be about where the Index is. The 440-gram headset consists of a front-mounted 185-gram core unit and a back-of-head-mounted battery. Valve uses an onboard Snapdragon 8650 ARM solution with 16 gigabytes of LPDDR5X for unified system memory and VRAM. The headset will have models with 256 gigabytes or 1 terabyte of storage, and the frame also has a micro SD card slot, so you can use that to install more games or software. It has pancake lenses, 2160 by 2160 resolution LCDs, a 120Hz refresh rate, and a 144Hz experimental mode. FOV is up to 110 degrees. The 4 exterior cameras are monochrome but IR sensitive, and the headset itself contains exterior IR illumination. Valve uses 2 internal eye tracking cameras for its new Foveated streaming feature that we'll get into momentarily, and audio deploys 4 speakers built into the head strap and 2 microphones in the headset. Valve also has a PCIe Gen 4 custom connector at the front of the headset for future accessories or attachments, potentially they say for third parties to use, with an example given of support for a color camera. The headset can also stream games directly from a PC using a 6 GHz included USB router, bypassing traditional wireless routers for the rest of your network and communicating straight between the PC and the frame itself. The controllers have capacitive sensing for finger tracking, TMR thumbsticks, which are identical to the ones used in the new Steam controller, and a full set of standard controller buttons. They take regular AA batteries, and to quote Valve's spec sheet, they have, quote, full 6 degrees of freedom tracking and IMU support, end quote. Now, the frame's SoC is an ARM solution, so an ARM solution in a VR head mount device is not that interesting, but SteamOS on ARM is pretty interesting because thus far it's been on x86. So Snapdragon 8 Gen 3 8650 SoCs are used for the Steam frame. These are on a 4nm process. And as for SteamOS on ARM, that includes ARM native compilations of DXVK and of VK D3D or Vulkan D3D. And it's also the first time that SteamOS is meaningfully expanding outside of handhelds, at least from any kind of first-party positioning, and into, for example, VR headsets. Now, the Steam machine's also going to get a SteamOS, but that's built for x86. So it's a Zen 4 solution, BGA, as we talked about earlier in this video. The Proton translation layer for SteamOS software compatibility was already pretty successful for Valve. They put a lot of effort into that. This is using significant development resources for FEX, F-E-X, emulation in addition to the Proton translation layer.
Similarly to how for Steam Deck we had to make a lot of advances in Proton to make sure that was really solid before Steam Deck could be an actual viable product. For Steam Frame, We did a lot of work on FEX, which we see as a
Is it a translation layer?
it's actually an emulation layer.
Oh, okay.
So it's like emulating the instruction set from x86 to ARM.
Cool.
And then so it's actually doing both Proton and FEX so that you can play x86 games standalone.
As for software compatibility, like the existing DEC verified program, Valve will be introducing a Steam Frame verified program specifically for running games locally on the frame.
In a similar way where when we launched Steam Deck, we had a lot of work to do on Proton, and as time went on, we patched a lot of the holes, and then it became more of a surprise when a game didn't work through Proton on Steam Deck.
Right.
We're doing this. We're in the same process with FEX as well. So like right now, we're pleasantly surprised that so many games are just working, and we know that once we get these into developer hands, we'll be able to learn a lot more, and ahead of launch, we'll have a sizable library.
Valve also told us that developers will be able to ship VR APKs on Steam, and for games with multiple versions, Steam will automatically choose the appropriate build, but it can be overridden. Valve stated, quote, APKs can also be side-loadable, just like any non-Steam applications on Steam Deck. We expect that VR APKs that don't leverage proprietary APIs to just work, end quote. The microSD card slot should theoretically allow for seamless library swapping between other SteamOS devices and the frame, like the Steam Deck and feasibly the Steam Machine, on a single SD card. This is something that Valve confirmed, as we talked about earlier, for the Deck to Machine sort of transition, and it should work the same to the frame. The only thing we're not 100% sure about there is the architectural change between them with ARM coming into the mix. So we'll still have to test this stuff, of course. Valve is pushing the use your headset as your display approach, even for non-VR content. Thus far, nobody, including Apple even, has been able to fully sell a mainstream audience on this approach.
So I would say Steam Frame kind of represents a fundamental shift in the way that we think about VR. Rather than being a PC VR accessory for your PC VR titles, we see Steam Frame as just a new way to experience your entire Steam library, whether it's VR or non-VR. And that high-level decision kind of filtered down into all of the product-level decisions that we made for the product.
For the PC to headset streaming, Valve's big advantage here over Meta is that it has a gigantic library with years and years worth of games that were developed to run on actual gaming PCs. So doing that and then streaming it to the frame makes sense for them.
Every single device comes with a dedicated wireless adapter. This is a USB 3.
Okay.
And it's a 6 gigahertz native router. And it talks directly between your PC and this device. So there's a whole bunch of channels, and that allows us high bandwidth, high robustness, and low latency. And it's a dedicated link just between these two devices.
Right.
Similarly, this headset has 2 radios and antennas, which means we can guarantee that one of those antennas is locked off to this dedicated connection on 6 gigahertz, while Wi-Fi is talking on the 5 gigahertz spectrum simultaneously to your local router.
The dedicated wireless dongle isn't a new idea, but Valve has planned around it from the ground up. Valve told us that, quote, the Steam Frame headset is Wi-Fi 7 capable, and when paired to your existing Wi-Fi, other streaming features, including foveated streaming and simultaneous 5 and 6 gigahertz, are still available and work great, end quote. So it's not strictly required to use the wireless dongle. Alongside the dedicated wireless link, the second piece of Valve's pitch for local streaming is foveated streaming. The naming is inspired from foveated rendering, which is a related concept that uses eye tracking to deprioritize the screen area in your periphery and render it at a lower resolution. This allows for increased frame rate, and a high FPS remains critical for VR headsets to avoid motion sickness in users. Now, historically, when VR first launched, the target was 90 Hz, 90 FPS, to avoid any sort of really bad feeling. The devices these days can go a little bit lower, but still higher is going to be a lot better, with VR in particular. So these technologies are used to focus the sort of density of image quality to where the user's looking. Now, eye tracking updates every 8 to 12 milliseconds according to Valve, although the hardware could go faster. So this meets Valve's goal, they say, for stream quality while reducing power usage and getting the responsiveness they say they want. When we looked at Valve's debug tool, the company shows user eye position, which is pretty cool, and reflects the area of highest quality rendering based on that. We tested this for a minute or two at the end of the session. We couldn't immediately notice any lag in the render quality shifting, although we haven't had time to actually analyze it, of course. The software also showed where in the frame lifecycle and rendering pipeline the most time was allocated. It harkens back to some of our talks about simulation time error, animation error, and just frame lifecycles with Tom Peterson. Here's what Valve said about foveated streaming.
So what we're doing is at the streaming layer, we're calling it foveated streaming, where the areas that you're looking, we send essentially the full high-quality content at the highest fidelity we can. And then for everywhere else you're not looking, we're borrowing those bits and also throwing them at that place where you're looking. So for instance, if we had, say, 1/10 of the pixel area is where you're looking, which is a very common number, then that's effectively a 10x multiplier in effective bandwidth, quality, as well as reduced latency, because we can steer all of those bits to where you're looking. And that only works because the eye tracking is fast enough that as you look around the scene, we send the bits to where you're going to look before you land there.
Foveated rendering is already an established technology. Without that sort of baseline, it'd be hard to believe that foveated streaming could be reactive enough to not have some kind of downside. Now again, in the really quick testing we did, couldn't see any change, any difference in the image quality, meaning when I moved my eyes from here to here, it didn't feel like anything was left behind in that transition. And for people familiar with foveated rendering, that should be a pretty familiar experience. We still need to test it more, of course, but it looks promising so far. Now, there are a ton of variables involved with the performance here. That includes the performance of the host PC itself, the frame rate, things of that nature. But we did ask Valve for kind of a ballpark end-to-end total system latency when streaming, obviously contingent upon the frame rate, the performance of the PC. They were giving us a number of 10 to 20 milliseconds, and that is total end-to-end in a good use case condition, meaning that the thing we were trying to focus down on was the actual slowest link, being potentially is it the streaming itself to the device. And so 10 to 20 milliseconds was the target there. That includes encoding, transmission, and decoding on the other side. The target bandwidth is 250 megabits per second, and regardless of whether the headset is running wireless or wired, that's the baseline for that loose 10x multiplier that they mentioned in effective quality that Valve is claiming. Everyone seems pretty confused about the Quest 3's maximum theoretical bandwidth, so part of Valve's advantage here is that it's shipping the streaming hardware with the headset, so everyone gets a consistent high-performance experience, which is for streaming, it doesn't matter what router you have or whether your PC has a wired internet connection. Foveated streaming is also a system-level solution, so that means there is no additional developer support required. They do not have to explicitly build this in and support it for games. It's just there because it is a system-wide thing that's already in place. So in contrast to previous Valve headsets, the frame is a standalone battery-powered unit with inside-out tracking. No base stations, no mandatory wires if you're used to those. It ships with a 21.6 watt-hour lithium-ion battery. Valve also informed us that the Steam frame hardware is not cross-compatible with the Index and the Vive at this time. Valve claims that power consumption from nominal to peak loads can range from approximately 7 watts when streaming to more than 20 watts when running games on the headset itself. Power is heat, of course, so at 20 watts, Valve's thermal solution comes into play more. The headset is separated into two modular units, the core and the head strap. The face gasket is attached with magnets, so the grossest part of the headset should be fairly easy to replace or take off and clean. The core is fastened to the headset with 3 toolless clips. The core contains the optics, the compute, and the cameras. Meanwhile, the head strap contains the audio and the battery. And because everybody with a 3D printer is looking for a problem to solve, we're pretty confident that people will make quick use of the modularity in the design. We got a huge amount of detail on the frame's thermal solution and how it's supposed to keep the device cool. We'll of course have to test that, and keep the user's face cool. But we'll have most of that in an immediate follow-up because we went pretty deep on it with some of the engineers there. It's a really fun video. That's going to be a separate one on the channel, so subscribe to catch that. We're going to do some basics, though, for this one. The short version for today is that there are 2 heat pipes flanking the silicon, with the PCB area at the backside of the BGA package cleared to allow rear heat pipe contact and conduction through the PCB. Both of these heat pipes, there's one on each side of the SoC, route to a fin stack at the top of the headset near the brow line, and then there's ventilation pointed up, out, and away from the user. There's a single custom blower fan in the core module center that's governed by thermistors across the PCB in addition to chip sensors. The displays are hotspots, but that's not necessarily a problem here.
The display behaves really well when it gets warm. It's actually a benefit. One of the things you want in VR is fast transition times because we run at such high frame rates. I haven't explicitly said it, but we work on the low end from 72 all the way up to 144 hertz.
Okay.
And the best way we're able to get those fast transition times at the higher frame rates is through the warmth of the device.
Okay.
So you can go too far, of course, right? Like a lot of heat. This is an LCD system. A lot of heat in an LCD isn't good, but there's this happy medium in between where the device is warmer than ambient and can therefore achieve really fast times.
Valve provided justification for LCD over OLED, and that came down to what they said was, quote, FOV, iBox, cost, persistence, and weight, end quote. And to avoid blurring, the duty cycle for the LCD panels is a flat 8% at all frame rates, meaning that at 120 hertz with 8.3 millisecond frame times, for example, the illumination period is 0.67 milliseconds per frame. Sound is provided by 4 16mm drivers, that's 2 per ear, and Valve says that these have been tuned to cancel out vibrations within the headset.
The thing that's really interesting is when you integrate audio into a sensitive piece of equipment like the core module, where there's all sorts of tracking that's happening. The vibrations can be a limiting factor in terms of how loud the system can get. And so we've designed it with 2 speakers per side. They're actually oriented in different locations, in different orientations, so that they can cancel the vibrations at the IMU and the core, while actually still doubling the amount of sound that the user is getting.
Okay. Now, as with thermals, we have a separate deep dive coming up on the acoustics. So Joy from Valve's team, who you just saw in that clip, had a lot of information to share here on the acoustic solution, on the speakers. We're going to include that with our separate thermal video because it's basically just like a ton of hardware-specific information without getting into the sort of the actual use cases of it. It's really cool, though, and we'll put that up separately. Headphones can be supported by Bluetooth and 3.5mm adapters, and as for the controllers, Valve claims 40 hours of battery life. Depends on the AA's you use. Of course, you can use rechargeables if you want. And the controllers look similar to the Quest 3s at a glance, although Valve emphasizes, quote, input parity with traditional gamepad, end quote, which is part of its push to play regular non-VR games in VR. Basically, you get all the normal controller buttons in the normal places. Also, the capacitive grip sensing has a limited gradient for the fingers and on-off sensing for the thumb. We haven't yet tested the index for comparison, but for context, the finger tracking is a differentiating feature of the index. Valve has taken a 3rd stab at VR. This is a 2nd stab at Steam Machines, SteamOS, Steam Controller, and arguably the Steam Link is kind of reincarnated in here in some capacity. It feels justified in the wake of the deck's success, but as we understand it, Valve's been working on the frame since at least about 2019, according to one of the engineers we spoke to. So it's interesting context because that means Valve was working on that before the Steam Deck launched, and before the pandemic era VR boom, and also before the launch of Half-Life Alyx. The frame should be shipping to developers immediately, if not already, sometime in the near future. Up next, the new Steam controller, which is not called the Steam Controller 2, follows Valve's previous Steam controller, which was also named Steam Controller, but this Steam Controller memory holds that Steam Controller because it's overwriting it with the same name, because that Steam Controller was dumped on mass for $5. The new controller, not called the Controller 2, uses Valve's dual touchpad input and significantly repositions and reshapes the controller ergonomics versus the original Steam controller. Valve said to us that it benefits from the deck's popularity and showed that controller key mappings can transfer directly to this controller. The new Steam controller can connect to anything running Steam or the Steam Link app and connects via the controller puck for wireless. There's also Bluetooth or USB directly. The controller contains a lithium-ion battery that can be recharged through the puck or USB. The thumbsticks are TMR and have capacitive sensing. There's a gyro with grip sensing and what Valve calls, quote, more advanced and powerful motors for high-definition rumble in the grips. As for the inputs, they completely replicate the inputs found on the Steam Deck minus the touchscreen. The Steam controller puck is a dedicated USB dongle that connects to the device running Steam, so probably your computer in most situations, and it can connect to up to 4 Steam controllers per puck, and this is both spiritually and literally a successor to the original Steam controller dongle in that Valve told us that the wireless protocol comes directly from the original controller. Bluetooth is still an option, but it has its downsides.
So if you add multiple devices, they share the bandwidth, and then when that bandwidth runs out, you have issues with lag and dropout. Yeah.
But also, it's just different PCs have different Bluetooth capabilities, different RF environments. It's more about the consistency than anything. Like a device with good Bluetooth will do really well. It's just that the consistent device to device and the consistency RF environment what really comes into effect.
One of the more interesting things to us was the way Valve's antenna design works for the Steam controller.
One of the things for like ESD, when you have to go through compliance on a product, you have to zap it with the ESD gun, make sure that it's going to be good. With our antenna design, we landed on a design that solves the cost problem as well as ESD, because the antenna is basically grounded.
Oh, okay.
So if you hit it with ESD, it doesn't blow out the front end of the chip.
Cool.
So that was something that we learned on Index, and we brought that in for here.
Okay.
You
So
know,
cost and also just functional.
cost, functionality, and it actually gives us, we say we have a 5-meter range by getting the antenna away from everything else. The controller has a lot of stuff all packed in there. So where do you put the antenna where your hands aren't going to be?
Yeah, right.
Because you're always,
Yeah,
and there's
you're
lots of
holding it
different
wrong.
ways to hold a controller. Like if you hold the claw, right?
Yeah.
Where's the antenna? Well, I'm blocking it. So
Where does it end up if we look at the actual controller body? Where does the antenna end up?
So the antenna, you can see the thumbsticks are here, the antenna's there. So it's kind of right in the ideal spot where you're not putting your finger up here in normal gameplay.
A question we had here was if you have 4 devices connected through the same hub for the controllers, is there any concern of latency or dropout or other issues as a result of 4 devices just sort of sharing the same connection ultimately? And Valve claimed approximately 8 milliseconds of latency with the wireless connection to the puck, as they call it, but they did emphasize that performance should not worsen as more controllers are connected, up to, again, 4 for one puck. The Steam machine actually has the same functionality built in, basically, where it's got a dedicated antenna separate from the Wi-Fi and the Bluetooth antennas for connecting up to 4 Steam controllers, and those are mounted to the heatsink, which kind of gives them the best possible positioning in the Steam machine. Now the puck also functions as a magnetic charger with pogo pins. Valve says its conservative estimate for battery life is 35 hours. The battery is a lithium-ion pack. We asked about user serviceability and repairability of the controller in general, but specifically getting access to the battery if someone wanted to replace it. Valve said that it is intended to be user serviceable in the sense that you can get into everything with a screwdriver. They didn't talk about any plans to provide parts or anything like that, but it sounds like it's at least not hostile towards the user if you want to open it. In addition to the touchpad haptics already found on the Steam Deck, the controller contains more advanced haptics as well.
One example that helps is think of it like speakers. So like some speakers have really wideband performance and like they're pretty flat for a big frequency range. Some speakers don't, right? And they are like a bass that only operates in kind of very narrow frequency band. And so basically what we have here is something it's a linear motor that has a wider bandwidth so that it can replicate those higher frequency and different frequency waveforms better. So it's a better, higher fidelity speaker in some ways, just in the haptics world.
Right. Valve was also clearly proud of its TMR or tunnel magnetoresistance thumbsticks, which sounds like something that Magneto invented. And these are the popular successor to Hall effect sticks.
And you can see these thumbsticks. One of the things that, Hall sensor thumbsticks have been a big thing in the industry. TMR is kind of new to the scene. It solves some of the power problems that Hall had, and keeping the sensitivity.
Are these off the shelf? Are they customized for the sticks that you guys are using?
We work with external suppliers, and like we're not fully integrating the thumbstick into like the mechanical housings. But we're using off-the-shelf suppliers for these.
The controller contains a 6-axis IMU and capacitive grip sensing that can dynamically turn gyro controls on and off. And then the controller also contains LED markers in it, so if you're wearing a Steam frame and using that controller, it can detect its positioning. All right, so that's kind of the basics of what you need to know. We do have additional follow-ups. So like I said, we have a separate acoustic power and thermal engineering discussion on the Frame VR headset. I would encourage checking that out, even if you're not really into VR, because it is pretty interesting from just an engineering standpoint. And then we have a separate deck video coming up as well. We're excited to do the testing mostly because the Steam machine specifically is basically exactly what we are set up for here, where we do all the pre-built reviews, and it's the same process. So I'd like to do the Schlieren imaging testing on it. We probably run acoustics in the hemianechoic chamber. We could hook it up for extensive thermal, all that stuff. It should be a pretty fun test. Whether or not the device is any good, I don't know. We don't know right now, but we've got a lot we can benchmark on it. The most interesting thing other than that is probably going to be the OS in a more official Valve sort of authorized or backed way hitting desktop. we're already testing Bazite, but if SteamOS gets a more proper deployment on desktop, then we would definitely add that to the round for a suite of testing as well. So early 2026, it sounds like for all this, pretty early announcement in that regard. We asked why. They said they're mostly announcing it this early because they're going to start trying to get people into the dev kit program. And two things. One, as soon as they do that, everything will leak. And then two, I think they are trying to let people, game developers, know that dev kits will be available for a lot of this stuff. So anyway, prices and final release date are TBD, but it should be early 2026 for a lot of this. And that's going to be it for this one. Thanks for watching. Check back for the other coverage from the event we flew out to. And you can subscribe for all of that. Go to patreon.com/GamersNexus to support us directly, or check out yesterday's video where I talk about the time I spoke to the Secret Service, or at least someone from there who was very interested in, I won't spoil it. Check out the video. It's linked below. Thanks for watching, and we'll see you all next time.